approved by our very own Sarah Chuka for the past couple of months. Please step up and buy a bottle. The money goes to a very good cause to our community biotech lab. This first iteration here is not genetically engineered, but the money you donate will go towards genetically improved beer. So I strongly encourage you to buy these. These are how much, Sarah?
But suggested donation is $20.
Suggested donation is $20, but don't stop there. $20 and higher. You can get it for $20 at a steal. So they're up here. Please feel free to buy a bottle. So I guess Dan shanghaied me here to do this strawberry DNA extraction. I'm one of the co-founders, along with Dan, of GenSpace, scientific director of GenSpace. And what we're going to be doing here is an adults-only strawberry DNA extraction using Bacardi 151 as the organic solvent. So that's what makes it adults only, because we're going to drink this. So we first need a few ingredients, and this is really easy to do at home. So everything you see here, you can do at home. It's pretty cool. So what we first need to do is grab some strawberries, and the reason we pick strawberries is because A, they're tasty. They're easy to get. You can use other types of fruits. I've tried this with mangoes. I've tried this with oranges. That works really well. Pineapples don't work very well. We're going to add some pineapple juice in here. So strawberries work really well. They also have lots of DNA. They're octoploid. So we have 23 pairs of chromosomes. So we're diploid. So two sets, one from mom, one from dad. These are octoploid. So they have 8 pairs of chromosomes. So 8 times 7. So they have a lot of DNA. This is for PBS, right? Okay. So the reason we're using these strawberries in this bag is they're frozen. Okay. So we're using frozen strawberries for a reason, and the reason is we want to break them open and get the DNA out of the cells. And the freezing process does it. So if you put any kind of cell in a freezer, you get ice crystals formed because they're predominantly water. And ice crystals, as they spread out, they puncture the cells, and when they thaw out, you have a mush. So when you hear these stories about Ted Williams' head being stored in a cryogenic freezer, Al Gore does this. Walt Disney, I think, is frozen over the Enchanted Kingdom. That's a true story, right? So they have to pump this guy's body full of dimethyl sulfoxide or some kind of solvent that prevents ice crystal formation from occurring. So when you go to a laboratory and have cells frozen, you have to mix it with a cryoprotectant like glycerol or DMSO, and that allows you to pull the cells out of deep freeze without the cells being turned into mush. But here we want them turned into mush because we want them broken up and we want to get the DNA out. So if you're going to put your body into deep freeze, make sure they put you in a cryoprotectant. It's very important. So we're going to take a couple of strawberries here. We're going to put them in here. And the next thing we're going to do is we're going to add in a little bit of this Dole pineapple juice. Now, I'm using this pasteurized variety. It'll work okay because this is broken up pretty well. It'll work even better if you get fresh pineapple juice. The reason is pineapples have these proteolytic enzymes. I think papain is found in papaya. I forgot the one that's in pineapple. But if you get a meat tenderizer, you'll look in the label and bromelain, exactly. Thank you very much. There's bromelain, there's papain. So meat tenderizer has these enzymes extracted from papaya and has enzymes extracted from pineapple. And these enzymes, what they do is they break protein. So when you rub it on a steak, it gets all soft and mushy and easy to eat. And that's what happens when you eat raw pineapple. You get this tingly sensation because the pineapple is eating you while you're eating pineapple. So please don't pass out in a big vat of pineapple you consume. You might regret it the next day. So we're going to seal this up. I think I'm remembering everything. So this comes the fun part right here is now we're going to use some mechanical disruption to break these open and get all the DNA out. Whoops. You have to be careful. So what we're going to do is we're going to mush this all up. We're going to basically, this is the part where when we have the kids-only version with isopropyl alcohol and detergents and all the other nasty stuff. This is the fun part where they get to bash everything up and extract all the DNA. So you basically, the more you mush it up, the better. You get all this extraction happening. And now we're going to need a glass. So Will, if you can see, if you ever grab me a cup somewhere, one of these cups.
Oh, we're doing this.
We're going to get a big cup for us.
There we go.
And we're going to get some coffee filters. You can get a coffee filter, or you can get, right there, or you can get a sieve, like a stainless steel sieve. You basically want to get out all this, like, giant pieces of strawberry out. Now, it'll work with these big pieces floating around, but the DNA gets entangled in all this mess, and it's hard to get it out. Now, what I'm doing here, when I'm breaking it all up, DNA is a very water-soluble molecule. It's like it's like a long molecular spaghetti. It's very narrow. It's about 2 nanometers wide, which is 20 billionths of a meter wide. But in the other direction, it could be really long. It could be many inches long. So it's a very asymmetrical molecule, and it's really charged. So it likes to float around in aqueous solutions like water, pineapple juice. What it doesn't like to do is it doesn't like to float around in organic solvents like alcohol. So the higher proof, the better. So we're going to use this Bacardi 151 as an organic solvent to basically extract the DNA. So we're basically mushing this all up, and now what we're doing is once it's all mushed up, hopefully we've got enough strawberries here broken up, we're going to open this up and we're going to run it through our improvised filter here. And we're just going to get as much of this liquid as possible. So I'm going to hold this, and we're just going to let it drip out. So out of this strawberry juice, we have all sorts of molecules coming out. We have carbohydrates, we have a little bit of proteins. There's proteins wrapped around the DNA. Now, the reason I put this bromelain in this papaya, if it was really fresh, what it also does is it breaks up proteins, and the DNA is wrapped around these proteins called histones, like basically string around a spool, like thread around a spool. So by breaking up these proteins, you kind of release even more DNA. So that kind of makes it a little better, because you get a better extraction. Don't push too hard, it's going to break. And I've done this and broken it many times. So we're going to let it drip for about a minute, and then we're going to, ideally when you do this, it's nice to get a really tall, skinny glass, like a shot glass like this, or even taller. I found a couple of these tall ones in a party store. The reason is it kind of saves on the Bacardi 151, and you can get a nice layered effect, because you really want to have a nice separation between the organic solvent, which is going to float on top, and the aqueous solution of DNA, which is on the bottom. And the actual precipitation is going to happen at the interface. So I think that's enough. Let's see. Put a little bit more in here. So what's going to happen is when we pour the Bacardi 151 in, it's going to want to float on the top of this this strawberry juice. And some of that DNA that's at the interface level, which is between the solvent and the water, the aqueous solution, it's going to go into the solvent. And the thing with DNA is once it gets into this solvent layer, once it gets within the solvent layer, it's got no place to go to bind to something that's got a charge. And the only thing charged in the solvent is itself, because DNA is charged. The DNA is basically bound to a whole bunch of ions that are in the solution, so it's got a little bit of charge. So when it starts to stick to itself, it'll clump out of solution and basically form what's called a precipitate. And what you'll see, hopefully, if this works, is you'll see a cloud of DNA forming, coming out of solution, and then slowly rising to the surface. And this is basically what's done in molecular biology labs around the world, except they don't use Bacardi 151. And strawberries, they use a bunch of detergents like sodium dodecyl sulfate and other types of stuff that you don't want to drink. But it's the same principle. So we're going to pour a little bit in here. Pour a lot. And we're going to let this kind of sit for a while, and it's forming at this interface, but I wish I had a nice light here. A flashlight. So basically, I don't want to drip this on your phone. So we're getting this layer forming, so you really want to wait a little while. So, preparing these cocktails, and you wait, it's slowly going to rise, so you're going to see a little layer forming, a little separation layer. And there's little air bubbles stuck to to the tuft of DNA that's here.
You guys see it?
Yeah.
It's millions of years of strawberry DNA evolution slowly rising to the surface. And we're going to take a skewer and we're going to try to spool this DNA out. And I mentioned to you earlier that DNA is a really asymmetric molecule and that's very long, like a piece of spaghetti, and it's charged. So that asymmetricality, that length of the molecule, you could see it in a macro scale. So you can't see individual DNA molecules. They're only like 20 angstroms wide. But clumped together, all those millions and millions of molecules will basically, just like having individual thread in a larger cord, will come together, and you'll see this kind of gooey, snotty-like mixture come out stringy that you can pull out, and that's all the chromosomes of the strawberry that you can basically just lift off. And I want to give this a little moment because it's kind of cool when you wait. If you prepare these in a party, if you wait a little while, it starts to actually rise to the surface. Nobody light a match next to me, by the way, please. And you get to see this. So it's kind of slow, but I already see this strength, this separation layer forming, and it's going to actually. I'm beginning impatient here. It'll actually start rising if you give it enough time, and you're not as impatient as I am. It'll rise by itself until it gets to the surface. And you'll have this little ball of DNA. Now, the thing I kept asking myself, the thing people always ask me is, well, how does DNA taste like? If you were to try it now, it would taste like Bacardi 151. If you were to rinse this probably with like pure alcohol and air it out, there it is. If you were to air it out, I would suspect if I had to make a bet, it would probably taste tart because it is an acidic molecule. So, you can experiment. You can try it out. You can tell me what DNA in a strawberry tastes like. Probably doesn't taste like strawberries. I'm sure all DNA tastes the same. So,